हेलो व्यूअर्स, वेलकम बैक टू आवर चैनल। फील्ड थ्योरी के लास्ट लेक्चर में हमने Zn के बारे में डिस्कस किया था बाय द मेथड ऑफ कॉन्ग्रुएंस क्लासेस। और उन लेक्चर्स में हमने ये प्रूव किया था कि Zn इज ए कम्यूटेटिव रिंग विद यूनिटी एंड इन फैक्ट if n is a prime then Zn is a field with respect to addition and multiplication on the congruence classes. So in this lecture we present another method to prove that Zn is a commutative ring, and the method we will discuss here is the method of division algorithm. So here the set under consideration will be the set of remainders of a positive integer, that is, if n is a positive integer, then what will be the set here? The set of remainders of n when any integer is divided by n. So we will explain each and every concept to prove that Zn is a commutative ring with unity using the method of division algorithm. So without delaying, let's start the lecture. So as we discussed that the set is the set of remainders of a positive integer. So let n be a fixed positive integer. Okay. Then the set under consideration is S is the set of remainders when any integer is divided by this fixed integer n. So what is the set here? Set of remainders of the positive integer n. And everyone is very much familiar that when an integer is divided by a fixed integer n, then it may give the remainder 0, 1, 2 up to n minus 1. So this is the set of remainders of a positive integer. Now we will show that this S will turns out to be a commutative ring with respect to two binary operation, addition and multiplication. So first we will define a binary operation on S. Define a binary operation addition denoted by addition n on S as follows. So for this, choose two elements A and B belongs to S. Then what will be A addition modulo B is least non-negative non-negative integer when the sum A plus B is divided by n. And you know that what is the least non-negative? Non-negative integer is nothing but the remainder. So this is the remainder when A plus B is divided by n. Okay, and you know that the remainder is when any integer is divided by a fixed integer n, the remainder may be 0, 1, 2 up to n minus 1. So clearly this will be an element of the set because this is the remainder and remainder is 0, 1 up to n minus 1. Remainder may be any integer from 0 to n minus 1, and therefore if we apply this operation, then it will be an element of S, and it will be a unique element of S. So therefore, what does this imply? This implies that, let me clear it. This implies that is a binary operation on S. So this is a binary operation of S. Now we will use the concept of division algorithm here to proceed further. So by division algorithm, तो देखिए आपने a प्लस b को n से डिवाइड किया. Okay, so let q1 be the quotient and r be the remainder. So q be the quotient and r be the remainder. Okay, where q is the quotient, and r is the remainder when a plus b is divided by n. Okay, so it means r is the remainder when a plus b is divided by n. Okay, so this implies, what is r? R is, in our operation, r is this. Okay, because this is the binary operation on S, and it gives the remainder when a plus b is divided by n. So r is this. Okay, so you can write this as a plus b minus n q, where q is the quotient. So we will use this notation in throughout this lecture, and this is very useful observation, very useful notation to prove that S is a S turns out to be a ring with respect to addition modulo n and multiplication modulo n. Okay, now with the help of this fact, we will show that this operation is associative. So what is the claim here? We have to show that this operation is associative. That means this must hold. Okay, now take the left hand side, and we will show that left hand side is equal to the right hand side. This is the easiest way to prove the associativity. So this is, replace this by r1, where r1 is the remainder when a plus b is divided by n. So you can write this as this, where q1 is the quotient when a plus b is divided by n, and this is nothing but this. Okay, now replace this. When you combine these r1 and c with respect to the operation defined above, then it will be r2, and you can write here as r2 is the remainder when r1 plus c is divided by n. So you can write this as, where q2 is quotient and r1 plus c is divided by n, q2 is quotient and r2 is the remainder. Okay, so you can write this as R1 and C. Okay, since R2 is the remainder when R1 plus C is divided by N, so obviously R2 lies between 0 and N minus 1 because R2 is the remainder. Okay, so rewrite the steps again. R2 is equal to R1 plus C minus N cube 2. R1 plus C minus N cube 2. And what is R1? R1 is A plus B minus N cube 1. So replace the value of R1 is here A plus B. A plus B minus N cube 1. This is the value of R1 plus C minus N cube 2. So this is A plus B plus C minus N cube 1 plus N cube 2, or you can write this as A plus B plus C minus N cube 1 plus cube 2. So what is R2? R2 is the remainder when A plus B plus C is divided by N. Okay. Calculate the right hand side. So for right hand side, we have to compute this one. Okay, so let's call this vector as R3. So this will be R3, where R3 is B modulo C, B plus N modulo C. Okay, so this is the remainder when B plus C is divided by N. So if you divide B plus C by N, let Q3 be the quotient, then R3 is the remainder. So you can represent R3 in this way, B plus C minus N Q3. Okay. Now again combine A with R3, then suppose it will be R4. So what will be R4 here? R4 is this one, R3. Okay. So this is the remainder when A plus R3 is divided by N. So suppose Q4 is the quotient here. So R4 is the remainder when A plus R3 is divided by N. So let's retrace the steps. R4 is A plus R3 minus N cube 4. Now substitute the value of R3 back. So what is R3? R3 is B plus C minus N cube 3. Okay. So again simplify the terms. A plus B plus C minus N cube 3 plus cube 4. So this is, you can write here that this is the remainder when A plus B plus C is divided by N. Okay. Now since R2 is also the remainder when, so you can write here also it is the remainder when A plus B plus C is divided by N. So R2 is also the remainder when A plus B plus C is divided by N, and R4 is also the remainder when A plus B plus C is divided by N. Since the number A plus B plus C is same and every time you are dividing by n, so you will get same remainder, because remainder is always unique. So it means this implies R2 must be equal to R4, and this implies A plus B plus C is equal to A plus B plus C. So this establishes the associativity in S. Now we move to the existence of identity part. So next we move to the next step, existence of identity in S with respect to this operation addition n. Okay, for this let A be an arbitrary element of S, because S is the set of remainders of n, therefore the element A lies between 0 and n minus 1, and of course this is less than n. Now we expect that 0 will be the identity. Let us check that 0 will be the identity with respect to this operation. So combine A with 0 with respect to this operation, then this is the remainder when A plus 0 is divided by n. Divided by n. So this is the remainder when A plus 0 means A. Remainder when A is divided by n. Since A is less than n, so if you divide A by n, then A itself is the remainder, because A is less than n. Okay, similarly if you combine 0 with A, then again you will get A. So it means if A is an arbitrary element of S, then A with 0 and 0 combined with A give you A, and this implies 0 is the identity in S, because S has 0 element, 0, 1, 2 up to n minus 1, and 0 is acting as identity, and 0 lies in the set S. So 0 is the identity element of S with respect to this operation. Okay, now we will show that this is a group with respect to this operation, and we will emphasize that we have every element in S is invertible. So this is our next task, that we have to show that every element of S is invertible with respect to this operation. So again, choose an arbitrary element of S. Then we have two possibility. If this element itself is 0, then it is very easy to see that 0 combined with 0 is again 0, because if you add 0 with 0, then you get the remainder 0 when divided by n. And what is 0? 0 is the identity of S. So this implies if A is a 0 element, then 0 is the inverse of itself. Okay, now we will discuss the case when A is non-zero. So if A is non-zero, then we will expect that what will be the inverse of A. We check that n minus A will be the inverse of A. Okay, so what we claim? We claim that n minus a is the inverse of a. So for this, combine a with n minus a. So apply the definition. This is the remainder when a plus n minus a is divided by n, and this is equal to the remainder when a gets cancelled with a, when n is divided by n. And you know that if a a number is divided by itself, then what is the remainder? 0. Similarly, if you add n minus a to the left side of a, again then you get 0. So this means every element, in fact non-zero element, has inverse n minus a with respect to this operation, and 0 is the inverse of itself, and if a is non-zero, then every non-zero element has inverse n minus a. Now we introduce multiplication on the set S. So define a multiplication, namely modulo n on S as follows. So let a and b be any two arbitrary element in S. Then we define a multiplication operation on S by this. So what is this operation? This will give you the remainder when a multiplied by b is divided by n. So this will be the binary of, I will show that it will be a binary operation on S. Since AB is divided by n, and this operation will give you the remainder. Okay, so you can write this as AB minus NQ, where Q is the quotient when AB is divided by n. So this is the remainder, and you know that if any number is divided by, any integer is divided by n, a fixed integer n, then remainder belongs to the set 0, 1, 2 up to n minus 1, and this set is nothing but S. So it shows that this is a binary operation on S. This implies is a binary operation on S. So no need to show closure, because binary itself is a closure. Okay, now we will show that this operation is associative on S. So next target is associative on S. So what we will do, we choose any three arbitrary element A, B and C from S, and what we show, we show that you can group these three elements in this way, or you can group these three elements in this way, then result will be same. Okay, so let's pick up the left hand side and we show that the left hand side will give you the result as the right hand side gives. Okay, so our claim will be established. So choose the left hand side. See, so let we assume that this is R1. This means R1 is the remainder when AB is divided by N. So let us assume that Q is the quotient, Q1 is the quotient, then R1 is AB minus NQ1. Okay, so this is equal to R1 C. Okay, so let assume R1 when combined with C is R2, because every time you apply these operations you will get a remainder R2. Okay, so here we get the remainder R2, and you can simplify R2 as it is the remainder when R1 into C is divided by N, and suppose Q2 is the quotient here. Okay, so R2 is R1C minus NQ2. Now retrace the steps back. R2 is equal to R1C minus NQ2. Okay, now put the value of R1. R1 is AB minus NQ1 times C minus NQ2. Open the bracket. Maintain the grouping AB C minus N Q1C minus N Q2. So you can rewrite these step again. AB C minus taking N common Q1C plus Q2. Okay, since R2 is the remainder, so R2 belongs to the set S. S is nothing but 0, 1, 2 up to N minus 1. Mind it that this is a left hand side is a remainder. R2 is a remainder, and this is a quantity, this is a number lying between 0 to N minus 1. Now we will calculate the right hand side, this side. Okay, so consider the right hand side. So assume that B combined with C gives you the remainder R3. Okay, so this implies R3 is the remainder when B into C is divided by N. Let us assume Q3 is the quotient here. Okay, so R3 is BC minus NQ3. So you can rewrite this as R3. Okay, so now assume A combined with R3 is R4. So what you can write here, R4 is the remainder when A into R3 is divided by N. Suppose Q4 is the quotient here. So what you get, R4 is A into R3 minus NQ4. Okay, so this is R4. Now retrace the steps back. R4 is A R3 minus NQ4. Now substitute the value of R3, B into C minus NQ3 minus NQ4. Okay, open the bracket and maintain the grouping. B into C minus N AQ3 plus Q4. So what is R4? R4 is again remainder. Okay, so R4 again belongs to the set 0, 1, 2 up to N minus 1. So in this equation, suppose this is star and this is double star. Both R2 and R4, these are remainder. Both are remainder. Okay, when ABC is divided by n. Similarly, R4 is the remainder when ABC is divided by n. It means you are dividing the same quantity by n. One time you get the remainder R2 and second time you are getting the remainder R4, but you know that if the number is same, the remainders are same. Okay, so this implies R2 must be equal to R4, and this implies left hand side is equal to right hand side, and this establishes the associativity of this operation. So now we move to the step existence of unity in S. It means the identity with respect to the multiplication. Okay, so for this choose any arbitrary element from the set S. Okay, this implies A is an integer lying between 0 and n minus 1. What do you expect? That multiplication identity in multiplication generally turns as 1. Okay, so let's see what by the definition we have. This is the remainder when a into 1 is divided by n. So what is this? This is the remainder when a into 1 is divided by n, and you know that a is an integer less than n. This a is an integer less than n, and if it divide a number smaller than n by n, then what is the remainder? Number itself. So a is the remainder itself because a is less than n. Okay, similarly in the other case you will get the same result. So it means if you combine 1 with any element of S, then you will get the same element back. So it means 1 is the multiplicative identity, and identity in multiplication is generally termed as unity. So we have established the existence of unity. Now we will establish that this operation is commutative on S. So we have to show that this operation is commutative on S. Since you know that the remainder when AB is divided by n is same as the remainder when BA is divided by n. It means either you divide AB by n or you divide BA by n, you will get the same remainder. Okay, so this implies immediately you can say that this is same as, okay, for all A and B belongs to S. So it means this operation is commutative on S. Now we will establish distributive laws on S. So let us establish distributive laws. So there are two types of distributive laws, left hand distributive laws and right hand distributive laws, and these are studied under this. That so let's discuss distributive laws. There we have to show that this operation is distributive over this addition. Okay, so generally we have to show that let A, B and C be three arbitrary elements on S. Then what we have to show that left hand distributive laws hold. So what is left distributive law? That means multiplication is distributive over addition from the left hand side. That means you can rewrite this as plus. Okay. Similarly, what is the right hand distributive laws? It means the multiplication defined is distributive over addition from the right hand side. That means that is equal to okay. So I will prove the left hand distributive law for you, and you can retrace the steps to prove right hand distributive law. So let's check the first part. So consider the left hand side from the first part, and the technique will be same as we have done in associativity part. Okay, so let it be R1. So what is R1? R1 is this. So it means R1 is the remainder when B plus C is divided by N. So this is B plus C minus N. Suppose Q1 is the quotient. So you can write R1 as B plus C minus NQ1. Okay. Now let it be the A combined with R1 be R2. Then what is R2? R2 is this means it is the remainder when A into R1 is divided by N. Suppose Q2 is the quotient here. Okay. So retrace the steps. R2 is AR1 minus NQ2. So put the value of R1 here. So A, what is R1? B plus C minus NQ1 minus NQ2. So this is A times B plus C minus N times AQ1 minus NQ2. So rewrite this as A times B, because this is now ordinary addition and multiplication. So you know that ordinary multiplication is always distributive over addition. So you can separate these A dot B plus A dot C minus N times AQ1 plus Q2. So what is R2? R2 is the remainder, because R2 is obtained by the operation modulo n and multiplication modulo n on S, and it means R2 is the remainder. Okay, so R2 belongs to the set S. So you have to keep in mind that R2 is remainder. And what is the right hand side? You can connect R2 with the fact that R2 is the remainder when AB plus AC is divided by N. Okay, so right here, that means R2 is remainder when AB plus AC is divided by. Okay, now we calculate the right hand side. So see the right hand side. So right hand side is Let me correct it. See. Okay. So again, suppose this is R3 and this is R4. So you can write this as R3 plus. Now what is R3? R3 is the remainder when A into B is divided by N. So you can write here AB minus NQ3, where Q3 is the quotient when AB is divided by N. Similarly, represent R4 as, what is R4? R4 is this. So what is R4? R4 is AC minus NQ4. It means R4 is the remainder when AC is divided by N. Okay. Now see here, R3 and R4 are combined with respect to this addition. So assume that it will be R5. Now represent R5. R5 is R3 added with R4. So it means this is the remainder when R3 times R4 is divided by N. So let us assume Q5 is the quotient here. So R5 is R3 plus R4 divided by N. It means R5 is the remainder when R3 plus R4 is divided by N. Okay, so now retrace the steps back. What is R5? R5 is R3 plus R4 minus NQ5. Okay, substitute the value of R3. R3 is AB minus NQ3. And what is R4? R4 is AC minus NQ4 minus NQ5. So adjust the sides. AB plus AC minus NQ3 minus NQ4 minus NQ5. So it means AB plus AC minus N times Q3 plus Q4 plus Q5. So what is the left hand side? Left hand side is the remainder, because we are applying either addition modulo n or multiplication modulo n. It means every time you will get a number from 0 to n minus 1. So therefore R5 is also in the set 0 to 1 to n minus 1. So it means R5 is the remainder, because every member of this set is less than n, and therefore it is the remainder itself. R5 is the remainder. So what is R2? R2 is the remainder when AB plus AC is divided by N. And what is R5? R5 is also the remainder. R5 is also remainder when AB plus AC is divided by N. So it means R5 is also remainder. And you know that AB plus AC is a fixed number, same number. One time you are dividing it by n, you are getting remainder R2, and the second time you are dividing, you are getting the remainder R5. But you know that remainder is always unique. Therefore this implies R2 must be equal to R5. And what is R2? R2 is left hand side and R5 is the, so R2 is the left hand side, R2 is, and R5 is, it means distributive, in fact left distributive law holds in S with respect to these operations. Similarly, you can show that right distributive laws also hold in S. It means S have both left distributive laws and right distributive laws. It means you can say that the multiplication modulo n is distributive over addition modulo n. So from this onward, we will denote this set S by by Zn. Okay, so you can now conclude that. So what is the conclusion from all the facts? That Zn with respect to this addition and with respect to this multiplication is a commutative ring with unity. So this is the conclusion of this lecture. Okay students, that's all from my side. In the next lecture we will extend this result to search that what is the condition on n that it turns out to be a field, and you know that very well that it will be a ring if and only if n will be a prime integer. हमने we have proved this result by the method of congruences, but in the next lecture we will prove this result that it is a field when n is a prime by assuming that S is the set of remainders. Okay, so stay tuned for upcoming lecture. Thank you.